My name is GurmeetShehkar and I will be presenting the project titled Improve Resource Efficiency through Dynamic Loading Control. It's a SIP stream funded project and you can see the partners, our university, LKOB, OBB, Bullied and Nogyo. So what we are going to talk about here very shortly is the loading process in sublevel caving mines. So what happens, there are two nomenclature that I will be using. The first one being the rings, the subvertical drill holes that you make and blast, and then you load it through a restricted opening, which is called the draw point. So what happens is the moment you drill and blast a ring, it starts to mix with the waste or the caved material, and then you take it out from a very restricted opening. So essentially you are taking out among 10,000 tons of material through an opening of 7 by 5 meters. And that creates a problem of when to stop loading, because if you load too much, then you're loading a lot of waste. And if you stop too early, then you left ore in the draw point. And draw control deals with this problem. So it answers two questions. The first question it answers is the amount of material to be loaded. So if you have planned for 10,000 tons, should you load 10,000 tons, 8,000 tons, or 12,000 tons? And it tells when to stop loading. And essentially, this is the objective of this project. And the reason why we do this is because the better we do it, the more ore recovery we will get, and the reduced cost we will have for the mining, and also less generation of waste. So what we are doing here is we are trying to optimize two parameters here. The first one being the number of rings mined. As you can see, those are vertical rings. And why we do it is because the less rings we mine, the less is the mining cost and less is the sinking rate of the mine, which means you can prolong the life of the mine in some extent. And so we want to minimize this particular parameter. So we want to minimize the number of rings mined. The second thing that we are monitoring over here is the ore percentage. So essentially, the more ore percentage you have, the better ore recovery you have and the better profitability you have in the mine. And this one we try to maximize. The problem is that if you try to maximize one, the other also gets maximized. And if you try to minimize the other one, the other also gets minimized. So what you need is here an optimal solution, and which is basically a balance of these two forces and trying to control that. And we try to do it using a holistic approach where we first have on a macro level a probability model that we created that looks into the different draw control strategies and gives us the numbers of rings mined and the ore percentage for different strategies. And on the micro level, we have created an economic model which looks at each individual rings and tells us about the profitability of that ring and gives us an idea of when to stop loading. And we have created these two models, and now we are in the testing phase. So in the future, we will be doing some model modification and verification for both the Kirunawara and the Manbariat mines. And we will also be doing some mine tests. Thank you.